By the end of this lesson, the students will be able to explain the term heterogeneous system, calculate Kc and Kp for heterogeneous systems, judge the extent of a reaction based on the value of the equilibrium constant. The equilibrium system that we studied in the previous lesson is a homogeneous system, as all the reactants and products coexist in the same phase. A system where two or more phases are present at equilibrium is called a heterogeneous system. Indicate whether each of the equations shown is for a homogeneous or heterogeneous system by clicking the appropriate box on the right. Let us observe the thermal decomposition of calcium carbonate. When the reaction is carried out in a closed container, solid calcium carbonate, solid calcium oxide, and gaseous carbon dioxide are present at equilibrium. Click the Kc' button to obtain the equilibrium constant expression for the reaction. The volume of 1 mole of calcium carbonate is given as 0.0369 cubic decimeter. Click on the calcium carbonate label. The concentration of a solid is the ratio of its amount in moles to its volume in cubic decimeter. Click the 2 moles button. Note that the concentration of 1 mole of calcium carbonate is the same as that of 2 moles of calcium carbonate. What can you deduce about the concentration of a solid from this observation? Answer: the concentration of a solid does not depend on the amount of the substance present and is therefore taken as a constant. Click the Close button to close the window. Now, click the Rearrange button. The terms concentration of CaCO3 and concentration of CaO are constants and can be combined with the equilibrium constant. Kc is the new equilibrium constant. Since we are dealing with gases, we can also express the equilibrium equation in terms of pressure. Move the sliders to increase or decrease the mass of CaCO3 and CaO at equilibrium. Take note of the liquid level in the U-tube. Discuss your observation and click Next. The equilibrium pressure of carbon dioxide remains the same no matter what masses of solid calcium carbonate and calcium oxide are present, provided the temperature remains constant. As a general rule, the concentrations of pure solids and pure liquids are not included in the equilibrium equation. Click the Kp button to view the equilibrium expression. Summary: a system where 2 or more phases are present at equilibrium is called a heterogeneous system. The concentrations of solids and liquids are constants. Hence, concentration terms of solids and liquids are not taken into account when calculating the values of Kc and Kp. The dissociation of ammonium hydrogen sulfide is a reversible reaction. Click the Kc button to view its expression for this reaction. The equilibrium concentrations of ammonia and hydrogen sulfide are both 0.20 mole per cubic decimeter. Enter the value of Kc into the empty box and check your answer by clicking the Check Answer button. Click the Kp button. The total pressure at equilibrium is given as 0.60 atmospheres. Click PNH3 and pH2S. Enter the value of Kp in the empty box and check your answer by clicking Check Answer button. Summary. Kc can be calculated from equilibrium concentrations. Kp can be calculated from equilibrium partial pressures. We can use the numerical value of the equilibrium constant for a reaction to judge the extent to which reactants are converted into products. 3 reactions are shown, each with a different Kc value. Drag the slider for reaction 1 to the right. The point at which the slider stops indicates the extent of that reaction. For this reaction, very little of the reactants are converted to products. The reaction does not proceed at all before equilibrium is reached. As a result, the value of Kc is very small. Now drag the slider for reaction 2. The Kc value is close to 1. Appreciable amounts of both the reactant and product are present in the equilibrium mixture. Drag the slider for reaction 3. The value of Kc is large. The percentage conversion of reactants to products is high, and the reaction proceeds nearly to completion. Summary. The larger the value of the equilibrium constant Kc, the further the reaction proceeds to the right before reaching equilibrium state. Hence, more product is formed.